Example number 3. Suppose the crate's height above the ground is given by two equations. One in this case is quadratic and the second one is linear. How long after the crate leaves the aircraft does the parachute open? Express your answer to the nearest hundredth of a second. So we again want to find out how long, so that's the time that they're going to intersect, and B, they want the height at when it's going to open, so that would be the y coordinate. So this is asking for the x coordinate of the intersection, and this is the y coordinate of the intersection. So we're going to do this algebraically by setting one equation equal to the other, because what we can do is take this h value and plug it into this h value. So it's going to look like this. The linear one, negative 4t plus 500, is equal to the quadratic one because they're both equal to h. Now we're going to bring everything to one side. So I'm going to bring everything to the left side. So instead of it being negative 4.9 t squared, it's going to be positive 4.9 t squared. Minus 4t, and then we're going to have plus 500, and then we're going to move the 900 over, which becomes minus 900 equaling 0. So now we have 4.9t squared minus 4t minus 400 when we simplify the 500 minus 900. So this is a quadratic equation, so we can solve this. And the fastest way to do that would be using the quadratic equation, where a is equal to 4.9, b is equal to negative 4, and c is equal to negative 400. So we're going to plug it into the x equals, which in this case is t. So we're going to solve for t by saying t equals negative b plus minus square root of b squared minus 4ac divided by 2a. Our negative b value, so we're going to have negative 4 plus minus negative 4 in brackets squared minus 4 times 4.9 times negative 400, and that's all going to be divided by 2 times 4.9. So once we put this into your calculator, you should find that there is two answers. So if you put the positive 4 plus and then square root that value divided by the bottom, you're going to get one value is equal to negative 4.99, and the other value is 9.45 seconds. So this is in time in seconds. So it did want the answer to the nearest hundredth. Now this answer for time doesn't make sense because time can't be negative. So 9.45 seconds is the only one that makes sense. Now, once we find the time, we can use that to solve for b. So b is where you plug in 9.45 into either the first equation or the second one. So we can plug it into the second one because it's faster. So we know that h is equal to negative 4 multiplied by 9.45 plus 500. If you plug that in, h is going to be equal to 462.2 meters, but since it wants it to the nearest meter, we want to round our answer to be 462 meters. Okay, so that's our y coordinate of the intersection point. Now for C, they want us to verify. So we're going to take those two answers and we're going to plug it into the first equation. So we know that h normally is equal to negative 4.9 t squared plus 900. So we already know it's going to work for the second equation because we used the second equation to solve for the h. But now we're using the first equation to verify. So our height is 462.2, so we're going to use the less approximated answer, equaling 4.9. Our t value is 9.45 squared plus 900. So we're going to put the right side of our equation into our calculator. So put negative 4.9 brackets 9.45 squared plus 900 in your calculator, and you should get 462.4. Now the reason they're not exactly identical is because our answer that we plugged in was rounded, so that means it's going to be approximately equal to each other, so this works. So these are both solutions to the equation, to the problem. So that's how you verify. Example number 4, we're going to choose another method. The method that we're choosing now is called elimination. So this is another way that you can do these questions. Usually I choose this method when they're both quadratic. So what you want to do is you want to line up the equations one over top of the other. Now, in this case, we're always going to try to get rid of the y. So if the signs are the same, as you can see, they're both negative and they're both the same coefficient, what you're going to do is subtract the two equations. So when you subtract 6x squared minus 4x squared, you get 2x squared. Then negative x, you're going to subtract negative 4x, which gives you negative x plus 4x. So that's going to be positive 3x. Now, what should happen in this elimination process is when you get to the y's, when you do negative y minus negative y, you get negative y plus y, because the two negatives become positive. And that crosses each other off, so that eliminates the variable of y. And then negative 1 subtract negative 6 gives you 1 plus 6, negative 1 plus 6, which is positive 5. So now if we bring the 5 over, it's now a quadratic equation equaling 0, and now we can factor it to solve. So I'm going to use factoring to solve. So this is where you find two numbers that multiply to negative 5 times 10, so two numbers that multiply to negative 5 times 10, negative 5 times 2, which is negative 10, x squared, and it has to add up to the middle, which is 3x. So the two numbers that would work would be positive 5x and negative 2x. So they both multiply and add to those numbers that I have on the right. Now we can use box method, so you can use whatever method you want to factor. So I'm going to do box method here. I'm going to write 2x squared, the first term in the top left box, and the coefficient in the bottom right box. And the two numbers I found, negative 5x, are actually positive 5x, and negative 2x in the other boxes. Two numbers that multiply to 2x squared would be 2x, and I'll make this one a negative for this to work. And then, actually I'll keep it positive. And then 2x times x will give me 2x squared. And then to get negative 2x, I'm going to have to make this negative 1. And then over here, you're going to have a plus 5 for it to give you 5x. So that works because you can see that 5 times negative 1 gives you negative 5. So my two brackets will be the top, which is 2x plus 5, multiplied by the side length, which is x minus 1, and that's equal to 0. So that gives me x equaling 1 from this guy, and you set them both equal to 0, which is kind of what I did for the second one. I just knew that that was going to be the answer when I isolated for x. Here I would subtract 5 on both sides, giving us 2x equals negative 5. Divide that by 2. So x could also equal negative 5 over 2, or x could equal 1. Now, once you find one coordinate, you have to solve for the y coordinate as well. So this is where we solve for y. So we're going to plug in x as 1, for example, into the first equation or the second one. You have a choice. So we're plugging in 1 wherever we see an x. Now we need to solve for y. So this is going to be 6 minus 1, and we're going to bring the negative 1 to the other side, making it positive 1, and we're moving the y to this other side to make it positive y. So those guys essentially switch sides. So that should give you a 6 for y. So our coordinates would be 1, 6. So that's one possible solution. Our next solution, guys, is where we plug in negative 5 over 2. So I can use the first equation or the second one, so just to change it up, I'll use the second equation. So then I'll put that all in my calculator. Again, these guys will switch sides, and that means they actually switch their signs, so you're going to have to add 6 at the very end. So that gives me 41. So when these guys switch sides, you're going to get 35 plus 6 equals y, which is then 41 for y. So our coordinates will be negative 5 over 2, so that's the x coordinate, and the y coordinate is 41. So make sure that you always give coordinates for these solutions to the equations. To verify, we can always plug these into the other equation to see if left side equals right side. So that would be our verification. We would see for the first equation, if we plug in those both points, do they equal -1? And for the second equation, do they both equal -6? Example number 5. So again, we have two quadratic equations. So you have a choice to do either elimination or substitution with them. So you could sub in one equation into the other. So I'm going to show you that substitution works here as well. So we're going to take negative 0.1x squared plus 2x and substitute it in for h in the second equation. So now there's no h's if you do it properly. Okay, so we're going to bring everything to one side. So we're going to bring everything to the left side. So we're going to add x squared, add x squared. We're going to subtract 39x, subtract 39x, gone. And then we're going to add 378 to both sides, add 378 to both sides, gone. So what we should have left is you're going to have to take one coefficient minus 0.1, and you should get 0.9x squared. And then you should have 2 take away 39, which is negative 37x. And then there's nothing to add 378 to, so you're just going to add 378, and that's equal to 0. So this is again where you can use the quadratic equation. You can even graph it to solve for the x-intercept. So whatever you want to do to get the solution. So when I find my x-intercepts, there's actually two solutions for x that could possibly make sense. So when I solved this graphically by putting this into my graphing calculator and solving for the x-intercepts, I got that the x-intercept was 18.96 and the other one was 22.15. Both possible answers. So now what you have to do is plug it into the previous equations. One of them you choose. So I'm going to choose the first equation right here, and I'm going to plug them both into there. So I'm going to plug in 18.96 squared plus 2 times 18.96. And I'm going to solve for that, and that should give me about 1.96 meters. The other one, same thing, I'm going to plug in, and there should be a negative here, just to let you know. And so the next one, negative 0.1, you're going to multiply it by 22.15 squared plus 2 times 22.15. Once I plug those in, I should get, in this case, negative 4.75. Now, h represents height, and we can't have a negative height. So this answer doesn't make sense, which means that the only solution that is possible is having the horizontal distance be 18.96 and the height be 1.96 meters off the ground. So that's my final solution, and they're always written as coordinates. So this is to the nearest hundredth. And explain the meaning of the intersection point. So this is the horizontal distance and the height that the ball was caught, so this is for B, where the ball was caught. Okay. Okay, so that is what B is asking for. It's just the approximate distance and the height that it was actually caught at. Okay, so in this last exit task question, we're going to solve this using an algebraic method. So we can do substitution again, 2x minus 7 equals x squared minus 12x plus 4. So we're taking this and putting it into the spot of y. Move everything to the right side. So I'm always picking the side where x squared is positive. So it's going to be negative 12x minus 2x. And then we have plus 4 plus 7. So that's going to be x squared minus 14x. And then 7 plus 4 is plus 11. So I can use the quadratic equation. I can graph this, whatever method I want. And I should find that there's two x-intercepts. Two x-intercepts if I did this graphically, which would be 13.16, and the other one would be 0.84. So these are the x's. Now you need to substitute that in for maybe the first one because it's faster. So substitute 13.16 into the first equation, and you should find that the height is negative 5.33. Actually, it should be 19.33. So my first solution could be 13.16, comma 19.33. So that's one possibility. And the second possibility is where I plug in 0.84 for x. And I get the answer is negative 5.33. So that's my second answer. That is a possibility where the x-coordinate is 0.84 and the y-coordinate is negative 5.33. So those are both solutions that are possible because this is not a real-life scenario here. So this is the algebraic approach, and then our next lesson is working on the graphical approach, and then we want to, or the previous lesson was doing the graphical technique, and then we can always verify by plugging them into the quadratic second equation to see if left side equals right side. Okay, so that's a checking mechanism, is always check your answers, plug it back in, see if the left side equals the right side. So that's it for our lesson. I hope you guys understood that. Let me know if